The history of quantum physics is fascinating and rich in discoveries. It is often presented as a series of technical advances and decisive experiments. However, we can also see it as a process of intellectual growth, similar to the stages of human life. Before continuing, I invite you to subscribe to our channel and give like to this video, so you can be aware of more content on science and technology. Now, let's explore together the evolution of quantum physics. The childhood of quantum physics begins in 1900 when Max Planck introduces the amount of action. At this moment, it is not sought to establish a new theory, but to solve a specific problem. This initial gesture opens the door to a new conceptual universe. It is like a seed that germinates without yet knowing the soil where it will grow. At this stage, quantum acts instinctively, useful, but even without a full understanding of its meaning. Quantum childhood occurs between 1905 and 1909, when Albert Einstein's work begins to give life to the thing. The photoelectric effect reveals that light behaves as discrete packages of energy, which transforms the thing into something physical. Despite these advances, there is still no unified theory. Quantum is no longer a simple anecdote, but it still faces the challenge of coexisting with ancient concepts that do not fully fit. The adolescence of quantum begins with Bohr's atomic model in 1913. At this stage, rules are introduced to predict atomic spectra accurately, but the model remains hybrid and confusing. Advances are remarkable, but internal tensions also arise. Quantum finds itself in a brilliant but unstable moment, seeking its identity while facing contradictions. Between 1925 and 1927, quantum theory entered a more structured late adolescence, with contributions from Heisenberg, Schrödinger, and Born. Here, classical physics was abandoned and a new coherent language established. Quantum mechanics becomes a consistent system with its own identity. Although questions remain unanswered, quantum has reached a more mature and autonomous stage. The age of quantum comes with the works of Paul Dirac and others. In this phase, approaches are unified in a common mathematical structure, establishing quantum as the natural language to describe the microscopic. Finally, quantum enters into its possible senectude, a stage full of achievements but also of questions. Although it has generated key technologies, it faces challenges that impede a unified theory at all.